Hey, good day, everyone. So before we get started, does anyone have a question? Okay, so yeah, you can always stop me, right? If you have any question along the way. And first of all, let's go to the Blackboard course. I upload a couple PowerPoint for today's lecture, so you can open that, right? Just open the PowerPoint, and we're going to talk about the contents here. So chapter 1 is mainly on the linear equation and then the application of the linear equation. And we're gonna just do some quick review on both on those background informations of linear equation, functions, and also the application, right? So first of all, chapter 1 is focused on linear equation and the application. So on section 1.1, we're going to first review the Cartesian system. Okay. So section 1.1. And we're going to take a look at Cartesian system. So this is a very important element to understand the graph of the linear equation, right? So Cartesian system basically comes with two important elements. First one is x-axis and then y-axis. And then the intercept of x-axis and y-axis what we call origin, right? Okay, so origin is the intercept of x-axis and y-axis. And the order pair, right? In terms of order pair for the origin will be 0, 0. Okay. And also, since the x-axis and the y-axis have intercept, then that means basically these two axes split the entire region into 4 quadrants, right? We call this quadrant number 1. So we're going counterclockwise to set up those 4 quadrants. So quadrant number 1 and counterclockwise, this will be quadrant number 2. And this is quadrant number 3. And then the last quadrant is quadrant number 4. And within each quadrant, basically, xy values varies, right? So in the first quadrant, in terms of both x, y coordinate, x is positive, and then y is positive, right? They're both positive. Okay. And in the second quadrant, yeah, so this is positive sign, right? This is negative sign. This is positive sign, negative sign. So in the second quadrant, x value is negative, and then y value is positive. Okay. In the third quadrant, both x and y are negative, right? Both x coordinate is negative, and the y coordinate is negative. In the fourth quadrant, x coordinate is positive, and then y coordinate is negative. So that actually gives us a breakdown of all 4 quadrants, right? In terms of understanding these order pairs and the relationship between the quadrant and also the order pair. So, and any questions so far about this quadrant and the Cartesian system? And if you look at x-axis and then y-axis, so if let's say this is x-axis, right? So on the x-axis, we follow the number line, right? So basically it's a number line, right in the middle is 0, right? And then on the right-hand side is a positive number. Something like that. On left-hand side, that would be negative numbers. So this is -1, -2, -3, -4, and -5. Okay, so if you look at the x-axis, on the y-axis, very similar, right? Y-axis, if you look at it, right in the middle is 0, right? On top of it, above it is positive numbers. So this is 1, 2, 3, 4, 5, all positive. Yeah. Okay. Let me quickly rewrite it. So this is 1, 2, 3, 4, 5. They're all positives, right? Because it's above 0, and below 0, they're all negative. So this is -1, -2, -3, -4, and -5. Okay. And that just basically follow the number line properties. And also, let's take a look at how to locate some of the order pairs, right? So let's locate order pairs. Example. Let's locate following order pairs in the Cartesian system. So let's say we have 2, 3, and then -2, 3, 2, -3, -2, -3, 0, 0, and maybe 2, 0, and 0, 3. So anytime when you see order pairs, that means we're talking about point. So you can, this is what we call order pairs, and order pair is equivalent to points. In the Cartesian system. So you can just draw it, right? Draw the Cartesian system. And then here we just locate all those order pairs. Okay. So here the first one, x coordinate is 2, y coordinate is 3, and they both positive. That means it must be located in the first quadrant, right? Quadrant number 1. So it should be here. So x value equal to 2, 1, 2, right? And then y value equal 3, 1, 2, 3. And as you can see, if you draw this dashed line here, they're gonna have intercept, right? And the intercept is what we are looking for. So the order pair 2, 3 should be right here. X value equal to 2, y value equal to 3. Okay. And second order pair is -2 and 3. So -2, that's x value is negative. So it should be on the left-hand side of the 0, right? So this is -1, -2. So right here. And then the y value is +3. So the y value is right here. So 3 and -2, they have intercept. And this intercept is the order pair we're looking for. Okay. -2, 3. And if you look at the third order pair, x value is +2, y value is -3. So it should be located in the fourth quadrant, right? So down here, somewhere down here. So this is -1, -2, -3. X coordinate 2, y coordinate -3. So intercept is right here. And then the fourth order pair is -2, -3. So this is -2 and -3 down here on the third quadrant, right? They're both negative. X is negative, y is negative. Okay. And then 0, 0, that's what we call the origin, right? Origin should be right in the center area, right here. So this is 0, 0. And then we have also two special points here. One of them is 2, 0, the other one is 0, 3. So here the x value is 2, y value is 0. That means it must be located on the x-axis. So it's right here. So this point is 2, 0. And we also call this x-intercept. So the key characteristics of x-intercept is when y equal to 0. This is always true, right? And the last order pair, you see x value is 0, y value is 3. And when x equal to 0, that's what we call the y-intercept. So this is y-intercept. So 0, 3 should be located right here. Okay, so this is y-intercept 0, 3. So the most important thing about a y-intercept is x equal to 0. So yeah, so any question on this? All right. All right, so I guess you guys can try to locate this, right? You can try to locate these order pairs. Try. Okay. Let's say 3, 4. 4, 3. 4, -3. -3, -4. And also a couple more, -4, 0. And 0, 3. So you should try this on your own, right? So on a piece of paper or any program, you can try to draw this really quickly. I'll give you a couple minutes to locate all those order pairs. Okay. All right, so let's quickly go over the answer here. Okay, so again, you're going to draw the Cartesian system, right? Okay, with the x-axis and the y-axis. The first one, it's both of them positive, so must be located in the first quadrant. So x value is 3, 1, 2, 3. Y. This is origin, and then y value is 4. 1, 2, 3, 4. So the intercept, that's going to be the first order pair. You can label that 3, 4. Now we move on to second order pair, 4, 3. Again, they're both positive. First quadrant, right? So this is 4 right here, and 3, they have intercept. So 4, 3 is right here. Now, next one is negative 3, 4. Okay. Negative 3, 4. So x value is negative 3, negative 1, negative 2, negative 3. And the y value is positive 4. So now think about this. With respect to the first order pair and the third order pair, any observation, anything special about those two order pairs? Does anyone notice something about these two order pairs? Anyone want to share your opinion on this? What do you notice from the graph?
They mirror each other?
Yeah, exactly, right? So first of all, if you look at it, they're on the same horizontal line, right? Because the y value are the same, so they on the same horizontal line. More accurately speaking, actually it's symmetrical with respect to y-axis, because the distance from this order pair to the y-axis, and the distance from this order pair to the y-axis is the same, right? It's both 3. Right? Just look at the distance. So that means these two order pair actually are symmetrical with respect to the y-axis. 3, 4, and the negative 3, 4. Symmetrical with respect to the y-axis. Yeah. And also, yeah, totally, they pretty close. And then distance, the total distance between those two points should be 6, right? 3 units plus 3 units, so 6. Yeah. So it's something to think about. Now let's take a look at the other order pair, 4, negative 3. So x value equal to 4, and the y value equal to negative 3. So it's right here. Now I want you to pay attention to 4, negative 3. What do you notice about these two order pair? Anything special about those two?
They mirror over the x-axis.
Exactly, very good. So they're on the same vertical line, right? Like this vertical line, we can draw that, and we can conclude this vertical line is y equal to 4. And no, x equal to 4, right? X equal to 4. And also they are symmetrical with respect to x-axis. Very good observation. So 4, 3. And so they have some geometrical implications here. You know, we can utilize sometimes to solve some real world problems symmetrical with respect to x-axis. Okay. And now negative 3, negative 4. That's down here. Negative 3 and negative 4. This is negative 4. So okay, this is order pair. Now I want you to look at this order pair and this order pair. Anything special about those two? 3, 4, and then negative 3, negative 4.
Diagonal from each other?
Exactly, they are diagonal, right? So if you draw this, they on the same line basically. Again, it's gonna be on the same line. And what do you think? Are they symmetrical? Should be, right? Very good. They are actually. They are symmetrical with respect to the origin, right? So this origin symmetry here. So this is another thing about this these two special order pairs, 3, 4, -3, -4. So 3, 4, -3, -4 are symmetrical with respect to the origin. So actually we have three type of symmetry, right? In algebra, part, and then we usually look at it, from geometry perspective, and symmetry actually provide a lot of, useful informations, about these different order pairs, and also it helps a lot, right? Along, so symmetry with respect to the origin. And the last two order pair is -4, 0. And what type of intercept this is? You see y value is 0, right? So this is x-intercept. Since it's x-intercept, it must be located on the x-axis, right? So it's right here, -4. So it's right here. The y value, it has no vertical distance, right? It's only horizontal distance, so -4. So vertical distance equal to 0. Yeah. And then last order pair is 0, 3. So this is -4, 0. This one is 0, 3, it's right here. So it's located on the y-axis because x value equal to 0. 0, 3. So pay attention to those special points. Later on, when you graph it, this special points create some convenience in terms of graphing this. Now let's go back to the PowerPoint. So this is basically what is talked about from the first portion of the PowerPoint. I just try to let's just quickly review the PowerPoint, and then we'll get to the one of the application problems. This is from real world, and it's pretty interesting. Okay, so let me share the screen with you. Here we go. Okay. Go editing. Slideshow. Beginning. Okay, so we're on chapter 1, right? Chapter 1 is about straight-line linear functions. So then we talk about a Cartesian system as introduction. So basically, Cartesian system was formed by two real number lines, right? X-axis and the y-axis. And the intercept of those two lines is what we call the origin, right? Origin. And if the line is horizontal, then that means, so we have this type of notation for horizontal lines should be y equal to c, something like that, right? And then also this determines, how many units. So if it is horizontal, let me draw a horizontal line. Let's say draw the horizontal line. Its horizontal line is always parallel to x-axis, right? So for the x-axis, we're using this equation to represent the x-axis is y equal to 0. That's why for any horizontal line, the equation should be y equal to something, y equal to a certain number. So in this case, since it's 2, so it's y equal to 2. So that's why we're using this y equal to c representing the horizontal lines. Okay. And I mentioned that earlier, since x-axis could be a number line, right in the middle is origin, right? And on the left-hand side, it's the negative numbers. And on the right-hand side is positive numbers, negative, positive. And you see, you can just draw that, right? This is y-axis, same thing here. So that's why the intercept is its origin, right? And then above 0, that's positive. So this sign is positive. below 0, that's negative. Okay. So try to make sense of this Cartesian system. Okay. And the origin is the intercept of x-axis and the y-axis. So we're using point O usually to representing the origin, right? Okay. Now horizontal line, horizontal axis is called x-axis. Vertical axis is called y-axis. Vertical line is called y-axis. And you can just read through this after class, and then order pairs, right? So basically in the Cartesian system, one of the most important things is order pairs. And usually we're using x, y. X represent x coordinate or x value, right? X coordinate or x value. And then y represent the y value or the y coordinate. And given any order pairs, right? So again, this one is in the first quadrant, and we know that they're both positive, both x and y positive. And typically you draw perpendicular line towards x-axis and draw perpendicular line towards y-axis. So this perpendicular line right here, right? And that's why this is right angle here, perpendicular line. So then you form this particular, you form all the pair, and then you'll be able to locate the x coordinate and the y coordinate. So x coordinate could be viewed as a distance from the the point, and between the point itself and then the y-axis, right? This is the x coordinate right here, x value. Okay, and the y value could be viewed as the distance between the point and the x-axis. So this is y value. And we also call this x value is always horizontal, right? Horizontal distance. And the y value is the vertical distance. And this is horizontal distance. Yeah, that's just breakdown of the x coordinate and y coordinate, and then the meaning behind it. Okay. Okay. So x coordinate and y coordinate we mentioned already. So this is x coordinate, that's y coordinate. And those two coordinate determines the location of the point, right? So location of the point is determined by the order pairs, also determined by the x coordinate and the y coordinate. Yeah, so and then we go over some of the examples, a similar one to the one we did. So this is 2, 3 is right here. So from this accurately constructed graph, as you can see, again, this point A and point B, they are symmetrical with respect to the y-axis, right? And also point B and point C, they are symmetrical with respect to the x-axis. Okay, and then point C and point D, they are symmetrical with respect to the y-axis again. Okay, and then point A and point D, they are symmetrical with respect to the x-axis. And if you just look at this right here, what do we call this? Just look at this thing. It's rectangle, right? We call this rectangle. So a lot of geometrical shape could be constructed in the Cartesian system, right? Just like what we, just by simply plotting the first 4 order pairs, connecting each 2 order pairs or each 2 points, we'll be able to come out with a rectangle. And then we know that this side, the length of this side equal length of this side, and we can easily verify that, right? Because the distance between this point order pair, point C and point D is 4 units, right? The distance between point B and point A, that's 4 units. And if you look at the distance between point B and point C, you count 1, 2, 3, 4, 5, 6 units, right? Here, same thing. 1, 2, 3, 4, 5, 6 units. And then we verify it's a rectangle, yeah, because those two sides equal to each other. Those two sides equal to each other, and then this is right angle here. Okay. Right. And also, one quick thing is this order pair x comma y not the same as y comma x. So similarly, like we have 2, 3, right? It's definitely not the same as 3, 2. Okay. 3, 2 is right here. You see, point E right here, and point A is here. They're not located on the same place. That means they're not equal to each other. And this just give you a breakdown of all 4 quadrants. And then in the first quadrant, both x value positive, y value positive, right? And in the second quadrant, x value is negative, and then y value is positive. The third quadrant, x value is negative, and then y value is negative. In the last quadrant, x value positive, and then y value negative. And that just give you a breakdown of all the pairs within each quadrant. Okay. Now let's consider the following situation, right? So you have taken a summer job selling antique, and the sales manager, offers 2 options. The first option is fixed monthly salary of $2,000. Second option is base monthly salary of $800 plus 10% commission of the monthly sales. Which option should you pick? Okay, anyone want to share your idea? Like anybody want to share which one you will pick and why? Which one is better off? And let's say you, as personally on a personal level.
Isn't commission-based better?
Yes, you can argue that. And then why is that? Why commission-based is better?
Because, I mean, you have the probability of making more. It's not guaranteed, but you can make more than that $2,000 a month.
Okay, yes. So there's an upside potential, right? With the commission base. Is that what you're trying to say? So we have upside potential on that. Yeah, that's actually very, very true about this situation. And also, we talk about antique, right? So some of the antique could be pretty expensive, right? And if you, let's say you are a good selling person, and let's say salesperson, you are very good at selling stuff. And the more you sell, the more commission you get, right? But on the other hand, there's let's say some of you guys are new to the sales jobs and you're not good at selling stuff, then maybe fixed monthly salary $2,000 is better, right? Because of lack of experience, and then your personality, just not very good at selling stuff, then maybe $2,000 is more secure and then stable, right? So totally up to you. And then, but generally speaking, commission based is always have more potential to earn more monies, right? In the long run. So, but let's try to formulate this too using a linear equation. So I'm gonna do this. Okay. So let's just try to formulate this and then try to understand, can we formulate this using mathematical equations and try to understand from there. So now let me share the screen with you. Okay. So for the first option number 1, how do we come up with the equation to calculate the monthly salary? Any suggestion?
2,000 times X?
Okay, and where does X represent?
Any variable, it represents the number of months that the person is going to take up the job for.
Okay, that makes sense. But and let's just consider 1 month. Just for this 1 month, right? Just for 1 month. How would you write the equation to categorize this monthly salary? So I guess we can assume a variable, right? So let's say monthly salary, we can using Y representing monthly salary. We can do that, right? Using a variable to represent the monthly salary. So for option number 1, Y should be equal to 2,000, right? That's all. No matter how many antique you sell within a month, you always end up with $2,000. Okay. Okay, so that's how you formulate this particular scenario. And then for option number 2, now you have to consider the sales, right? Very good. So as you mentioned earlier, X representing the monthly sales. Okay. Now let's think about this. So the Y still representing monthly salary. Now what is Y equal to? Anybody come up with the idea?
800 plus 0.10x.
Very good. All right. So the base salary 800, fixed salary $800 plus 10%. That's 0.1. So you're converting 10% to decimal number, which will be 0.1 times x. Very good. So now think about this. If we want to compare these two options, we wouldn't be compared directly, right? Because you see, on option number 1 is $2,000. Option number 2 is $800 plus a variable thing, right? So this part is called fixed part. And this one is called variable part. And variable part is vary based on the monthly sales, right? So if you are really good at selling stuff, then you may end up with a lot of huge amount of the monthly sales. Now you may end up with a very high monthly salary. But if you're not very good salesperson, then that could be you end up with less money, right? Maybe less than $2,000. But do we know when those two options generate same amount of the money in terms of monthly salary? Can we figure out that? If we know that, maybe we can make a better decision about this scenario. So any suggestion? When option 1 and option 2 provides same monthly salary, when does that happen?
Well, you would only know after the month ends, because then you know how much you sell.
That's right. Hypothetical speaking, right? Let's say you haven't started a job, but you just want to consider trade-off. Let's say which option is better, and then also consider the monthly sales you have to generate in order to match the amount of fixed salary provided by option number 1. So you see we have the equation here, right? What if this 800 plus 0.1x equal to 2,000? That means those two options provide the same outcome, which is the same monthly salary of $2,000. And based on that, we'll be able to figure out the monthly sales needed to generate that So for option 1 equal to option 2, this has to happen, right? $800, yeah, no, let me do it the other way. So $2,000 must be the same as the other option, 800 plus 0.1x. Remember in the algebra course, you learn how to solve these linear equations, and this could be this could come from the real world scenario, right? This is very common scenario in a lot of sales jobs. Typically, you know, the manager will offer you these two options, you know, especially you are new to the field, you know. And yeah, so that should be something you consider, right? And let's see how can we solve for x. So right here, first of all, we subtracting 800 from both sides of the equation. Okay. Now subtract it, you get 1200 equal to 0.1x. Now you divide both sides of the equation by 0.1. Okay, then we get x values, right? So x equal to 1200 by 0.1 should be $12,000. That means in order to have the same monthly salary from both options, under option number 2, the monthly sale must be equal to $12,000. Okay, so then you have to assess, you know, whether this antique is expensive, or let's say it's not so expensive. Some of the antique could be worth, you know, $100,000, right? So even you sell just one item, maybe you'll be above $12,000. Then you end up with a more monthly salary. So totally up to you, you know. But at this point, you get better idea. You just have to have a sales of $12,000 to have the equal monthly salary under both options. But if you can sell more, generate more monthly sales, then you will make more money, right, in terms of monthly salary. Okay, so any questions on this? So there's no firm answer, right? In this case, it's totally up to the actual scenario. Depends on the price of the antique, and also the salesperson's personality, also like ambitions about, you know, all the skills of the selling stuff. You know, all this must be considered before you can make the right decision. But yeah, that's basically how you assess this, come up with the right equation, right? And then try to compare them. And work with the equation, try to get more information out of it. Okay, and this is actually what we're going to do from section 1.1 and then 1.2. Now let's move on to section 1.3. We have more stuff to go to review. Okay, so you can go to our Blackboard account and open the section 1.3, and let's go over that. And I'll also post the PowerPoint. Okay. And again, this is still about the review, right? Review about linear equations and straight lines. So some of you guys may already know this very well. So bear with me, right? So first couple lectures is we not introduce too much new stuff, but later on you're going to learn new content from finance, from business, you know. So, yep. So let's look at section 1.3 PowerPoint. Share that. Here we go. And let's get to it. All right. So now we're going to take a look at the different ways of writing this linear equations and a straight line. So straight line could be applied in different fields, right? Business field, you know, finance field, a lot of fields. If you run a business, right, you usually would purchase, you know, assets like buildings, machines, furnitures, vehicles, and equipment, right, over a period for income tax purposes. And since you purchase this assets, you could depreciate it. And that one of the important terms called linear depreciation. Or another way of saying that is straight line depreciation, straight line method. So for example, let's say you purchase a machine for let's say $20,000. And then the life of the machine is 5 years. That means for income tax purposes, every year you'll be able to depreciate $4,000 of the machine by simply dividing 20,000 by 5, right? You get $4,000 per year, 5 years. So that means every year on the corporate income tax return, you'll be able to depreciate $4,000, subtract $4,000 from the income of the company per year. So this is a very famous term called linear depreciation, because it follows the linear, the relationship is linear, meaning as a year go by, the value of the machine go down by $4,000. Similarly, another year go by, the machine depreciates another $4,000. That's why it's called linear depreciation or straight line depreciation. Okay. And now let's take a look at this particular example, right? So graph of the straight line below describe the book value of network server. Okay, so the company is using a network server and it has an initial value of $10,000 and that is being depreciated linearly over 5 years with the scrap value, meaning residual value, right? It's the same thing as residual value. Residual value meaning after depreciation, the value remains for the machine, residual value. So now we try to formulate this. So now let's think about this. Can we come up with a linear equation to describe this process of depreciating this network server? How can we do that? Any suggestion? So we will try to model this using linear equation. Model this scenario using linear equation. Let's think about this. Initial value, meaning when you purchase the machine. So there are two elements here. One of them is time t, right? The other one is the value of the machine. So for the initial value, meaning when time t equal to 0, the value of the machine is $10,000, right? So this is first scenario. Now the second scenario is after 5 years. The value of the machine becomes $3,000. So now this is first condition. Second condition is when time t equal to 5, then the value of the machine equal to $3,000. Okay. So now we know that this is depreciation, meaning the value goes down. So the line is decreasing, right? Meaning every year go by, the value of the machine goes down. Now, can we know how much does it go down per year in terms of value? Okay, so on a yearly basis, right? So we have originally have 10,000. Okay, so we can set up we can use in the slope representing the steepness of the line, meaning slope give us a better idea, you know, the value of the amount of value goes down on a yearly basis. So you can assuming this is V1, right? This is V2, and this is T1, T2. So you can do V2 minus V1. That's total amount of the value go down on a yearly basis over T2 minus T1. So then the V2 is 3,000 minus 10,000, and then dividing by T2 is 5, right? 5 minus 0, that's 5. So 3,000 minus 10,000 is minus 7,000 divided by 5. Now when you do the calculation, it should be negative 1400, right? So meaning every year the value of the machine will go down by $1,400. Okay. So now we know the slope, right? Slope is negative because negative slope indicating is going down. So the value of the machine go down on a yearly basis. And also, if you're using this V, then we do slope times time, right? Plus V0. V0 is the initial value of the machine. So value of the machine should, after any year, should be negative 1,400 times time plus V0. Initial value of the machine is $10,000. So plus 10,000. So here T representing time in years. And then V represent value of remaining value of the machine. Remaining value. So now one follow-up question. Could someone figure out when does machine become obsolete? Meaning the machine has no value at all. After how many years the machine becomes useless or has zero value, zero residual value? Since we already now have the equation to represent in this scenario, right? Any suggestion?
V equals to 0.
Yeah, very good. So setting V equal to 0, right? Perfect. When V equal to 0, that means machine has no value at all. So that means negative 1,400 T times 10 plus 10,000. That's equal to 0. Okay. So now in order to solve for T, you just have to subtract 10,000 from both sides of the equation. Okay, we get negative 1,400 T equal to negative 10,000. Then you divide into that, and T is equal to 10,000 by 1,400. And as you can see, we can just divide into that. Okay, so 10,000 is not going to be a rounding number. It's going to be a decimal number. 1,400 is 7 point something, right? So it's approximately equal to 7.14. So that, what does that tell us? When does machine become useless?
In about 7 years.
Exactly. Yeah, about 7 years, right? Between 7 to 8 years, the machine becomes obsolete or becomes with a zero residual value. Okay. So this is actually application of this straight line depreciation in the business field. And no matter what field you go into, right? So this is in a business field, you always have to deal with this particular tax scenario in terms of depreciation. And now let's go to the slope of a line. Okay, slope, we're using M to represent slope, right? And slope is what we call measures the steepness of the line, right? Steepness. And slope is equal to vertical change over horizontal change. Vertical change over horizontal change. And vertical change, we're using delta Y, representing vertical change. The y value is vertical, right? Vertical change. And then delta x represents horizontal change. And to be more specific, given two order pairs x1, y1, x2, y2, now the vertical change could be captured by subtracting y2 by y1, right? So y2 minus y1 represents vertical change, and then x2 over minus x1 representing the horizontal change. So graphically speaking, this is a vertical change, right? That's horizontal change. And then the quotient between those two, that's a slope. And the slope is also, if you look at this angle right here, assuming it's theta, right? So slope is also equal tangent of the theta. Because for the tangent, this is one of the trigonometric function. Tangent is opposite over adjacent. So opposite is the vertical change, and adjacent is a horizontal change. So that's why slope is vertical change over horizontal change. And this is where this famous formula comes from, right? And in terms of it's from trigonometry. It's like the application of the trigonometry in this Cartesian system. Okay, so just help you understand this background information about the slope. Okay, now take a look at this. This is what we call the vertical line, right? What happened to vertical line? Is there any slope? So if you do slope equal to y2 minus y1, right? Over x2 minus x1. However, you see x1 and x2 equal to each other. Here, because it's vertical line, so x1 equal to x2. So what it's saying is it's y2 minus y1. Since these two equal to each other, that's 0. So we have a value over 0, so this is undefined. This is exactly one of the case which is undefined, right? We did something similar last week Friday in the project, Excel project about the undefined because it's division by 0. So same thing apply here. So that's why for all the vertical lines, there's no slope. Okay, so slope is undefined. Okay. And you can easily verify that using the slope formula, right? So try to memorize this slope formula is very important. So given any two order pairs, you can always use slope formula to calculate the slope. Okay. Yep. And typically delta y is what we call the vertical change, right? And then delta x is horizontal change. So the ratio of those two becomes the slope. And that's how you look at it graphically. And now let's think about this. So this slope equal to 2 because vertical change is 2 units, horizontal change is 1 unit. So 2 over 1 gives us 2. So if you know the vertical distance and the horizontal distance, then you just divide them to get a slope. And then here, since slope is positive, as you can see, the line is going up, right? From left to right. When the slope is greater than 0, then the line is increasing from left to right. We also call this increasing line, right? From left. Increasing line, and we also have a decreasing line in the next slide. So right here, this is a decreasing line because vertical change is -1, right? So this is delta y. So delta y equal -1, delta x equal to 1. So slope equal to delta y over delta x. So it's -1 over 1. And that's why the slope is -1. And as you can see, the overall trend of this line is going downward. So the line is decreasing line. So when the slope is less than 0, generally speaking, when the slope is less than 0 and the line is decreasing. And we also just simplified from left to right, right? Again, from left to right. Okay, so we also call this a decreasing line. And this just shows different slope and how it changes. And let's compare this. Slope equal 2, 1.5. And what do you notice? How do we distinguish those 3 lines with 3 different slopes? Any suggestion? Let's say you just throw out 3 slope, and then how to distinguish them with a simple language. Now let's take a look at the bigger slope, m equal to 2, compared to the smallest slope, m equal to half. It looks like the bigger slope has steeper. The line is more steeper, right? Meaning, when slope is bigger, the bigger the slope, the steeper the line. Meaning, it's increasing faster. So the line is increasing at a faster pace. It's increasing at a faster pace. Now, okay, so this is positive side, right? And now let's take a look at negative side. Anyone want to share your observation about the negative slope and how to distinguish different slopes with the same negative side?
It wouldn't be the same way you just did that, viewing the steepness of the slope. It's really just mirrored, and instead of it increasing, it's just decreasing.
Exactly. So as you can see, the absolute value of m equal to -2, actually, it's bigger than the m equal to -half, right? So still, it follows this. The bigger the slope, you see, in this case, in terms of absolute value, the bigger the slope, the steeper the line, meaning that the line is decreasing at a faster pace. So, so on the negative side, so this is true for all the positive lines. Okay. For the negative slope, if we just focus on for all the negative lines, negative slope. Okay. Actually, the smaller the slope, the steeper the line, meaning the line is decreasing at a faster pace. So the smaller, because -2 is smaller than -half. Okay, the slope, smaller the slope, the steeper the line. So the line is decreasing at a faster pace. Line is decreasing at a faster pace. Okay. So that's how you distinguish, all the positive slope and then a negative slope. But if you look at absolute value, right, they are the same actually. So usually, if you just consider the absolute value of the slope, the bigger the absolute value of the slope, the steeper the line, right? Okay, and that's how you distinguish those. Now, let's sketch the straight line that passes through the point -2 and 5, has a slope -4/3. Okay, so now we just simply sketch using the given point and also slope. So I'm going to show you how to do this really quickly. Okay, so first of all, we're gonna nail down this given order pair. So the point -2, 5 is located on the second quadrant. So this is -2. 1, 2, 3, 4, 5. Okay. So they're gonna have intercept, right? So we are starting with this particular point. And start with that point. Secondly, we're gonna utilize the slope here. Slope is -4, right, over 3. So slope is vertical change over horizontal change. It's delta y over delta x. And vertical change, since it's -4, -4 meaning we're gonna go down 4 units. So -4 go down. On the vertical side, if this vertical line negative, meaning go down. If it is positive, go up. And on the horizontal side, if it is negative, goes to the left, right? Go to left. And then positive, go to the right. Okay. So right here we have we're gonna go down 4 units. So 1, 2, 3, 4, and then go to the right because it's positive. Go to the right 3 units. So first of all, we go down 1, 2, 3, 4 down here, and then go to the right 3 units. So this is 1, 2, 3 right here. Start at 1. Okay. So now we nailed down another point. Okay. By utilizing this slope, right, to locate the other point. Now, once you have 2 order pairs to go point, and then we connect them, extend it, we get a line. Right? So you just connect those 2. Just go back a little bit.
Professor?
Yes.
Just a quick clarification, because I'm looking at the fraction, and it says, so it's not -4, -3. It's just the negative applies to the top number, and the bottom number is a positive.
Exactly. Very good.
Okay.
Very good observation. Yeah, this is exactly what we try to separate them, right? We put a negative sign on top. You could also put a negative sign on the bottom. You will generate the same result, right? You end up with the same line. But yeah, typically we just put it on top for convenience. Okay. And
Thanks.
no problem. Yeah. Okay. So now you connect those 2 points. Extend in both directions, you get a line, right? And then that's exactly what is happening on the other. So we end up with a decreasing line here. Okay. But this is what goes behind it, right? So first of all, nail down the given order pair, and from there, utilize the slope to get another point here, then connect them with a straight line. Okay. Any question on this? All right, very good. So let's move on. Now, let's try to find the slope of the line that passed through the points -1 and 1. And so basically, anytime if you want to find the slope, you use a slope formula, right? So y2 minus y1 over x2 minus x1. So here, this is, we label this x1, y1. First order pair is always x1, y1. Second order pair x2, y2. Now we're just throwing all the numbers into the formula. So y2 is 3, y1 is 1, x2 is 5, and x1 is -1. It's minus -1, right? So make sure you do not skip any negative sign here. Otherwise, your result will be off. So now we have 3 minus 1 is 2 over 5 plus 1 is 6. 2 negative turn to positive, so 5 plus 1 is 6, it's 1/3. So this is positive slope. That means it's increasing line. just based on the slope, we'll be able to figure out, whether it's increasing or decreasing. So if you plot both order pairs, right, -1, 1, and then 5, 3, and connect them, you see from left to right, it's increasing. So that means we have the right result. Okay. All right. So yep, that's how you calculate the slope. So horizontal line has a slope of 0, right? So for all of horizontal lines, slope is always 0. So this is most important characteristics of all the horizontal lines. Horizontal line, so if you look at x-axis, right? This is also a horizontal line. So slope for that x-axis is also 0, according to this particular principle. And we can use the slope of a straight line to determine whether a line is parallel or to another line. So if two lines, as you can see, this is another horizontal line. Let's say this is 2, right? And they have the same slope because they have this, they are both horizontal lines. The slope are the same. So here, when two lines are parallel, meaning their slope must be the same. Okay, so two lines are parallel, M1 equal to M2, right? Two slope equal to each other. So parallel lines, so putting the simple, abbreviation will be parallel lines. Indication of that is both slope for line 1 equals slope for line 2. Okay. So this is the best way to categorize all those parallel lines. Okay. And now let's take a look at the example. Okay. So that L1 be the line passed through -2, 9, and then 1, 3. And then the L2 is the line number 2, passes through the point -4, 10, and then 3, -4. Determine whether or not they are parallel. And how do we tackle this problem? Any suggestion?
Find the slopes for both.
Exactly, very good. So for line number 1, we have two order pairs, right? -2, 9, and then 1, 3. So you find the slope using the slope formula, x1, y1, x2, y2. Now we just apply the formula y2 minus y1 over x2 minus x1. And now we throw in the values. So 3 minus 9 over 1 minus -2. So 3 minus 9 is -6 over 3, right? So it turned out to be -2. So for line number 1, slope number 1 is -2. So now let's take a look at line number 2. We've given two order pair, -4, 10, and also 3, -4. We still label this x1, y1, x2, y2. Now let's calculate the slope for line number 2. So we do y2 minus y1 over x2 minus x1. So this is -4 minus 10 over 3 minus -4. So on the top, two negative numbers remain negative, and adding in those numbers, -14. On the bottom, 3 adding 4 becomes 7, right? So simplify, you get -2. Now you compare M1 and M2. Since they are the same, so since M1 equal to M2, that means those two lines, L1 is parallel to L2, parallel to L2. So using slope, we can quickly check this, right? If they are not parallel, then the slope are not equal to each other. Okay. Yep. And if you draw the graph, you will see that, you see, this is line number 1. You plot both points, you get that. You plot line number 2 using two order pairs, you get that. And they are exactly parallel to each other, meaning they have the same steepness, right? Okay, any question on this? All right. So now let's move on to equation of the lines. We have several different formulas we can use to get the equation of the lines. And first of all, let's look at some special cases. First case could be a vertical line, right? So if you look at a vertical line, one thing is you see the x value is always the same, right? So for all the vertical lines, the equation should be x equal to a, right? Whatever that x coordinate is, so that will be used to representing the vertical lines. So this is general equation for all the vertical lines, because the x coordinate remains the same no matter which point we look at. Okay. And then we also have x equal to a, right? That's the final conclusion about this, all the vertical lines. And here, this line x equal to 3, right? That's a vertical line. And this line is x equal to -2 because x coordinate here is -2. This x coordinate is 3. And they are parallel to each other, right? You can draw another. Let's say there's another vertical line here, right? Here it is 5. So that means the equation should be x equal to 5. Okay. As you can see, they all have the same structure of the formula, x equals something. And remember, for all the vertical lines, how about the slope? Is there any slope associated with the vertical lines? I think we talked about this earlier, right? The slope of all the vertical lines is undefined, right? Slope is undefined. Okay. Because the denominator is 0, right? Because x value is the same. So the horizontal change is always 0. So that's why slope is undefined. And now let's look at point slope formula. So if you know the slope of the line, and then we also know the given point x1, y1, then the equation of the line could be given as y minus y1 equal to slope times x minus x1. So this is what we call the point slope formula. Formula of the line. You can always use that, to get the equation of the line. All right, given the point and slope. Okay. Now let's take a look at this. So we are given this 0.13, and then we know the line has a slope of 2. Now we need to find out the equation of the line. Okay. So here we actually know a couple of things, right? Slope 2, meaning m equal to 2. And from here, our first order pair is x1, y1. That means we know m slope here, 2, x1, that's 1, and then y1, that's 3. Okay, so now applying the point slope formula here, and then you plug in the slope, plug in x1, plug in y1, right, into the point slope formula, and then you'll be able to get the equation of the line. So this is basically y minus 3 equals slope 2 times x minus 1. Okay, and now you distribute it. Okay, so y minus 3 equal to 2x minus 2. Right. So we're gonna get y by itself by adding 3 from both sides of the equation. Okay. So we end up with y equal to 2x adding 1. Come up with the equation of the line. And as you can see, since slope is positive, meaning it's increasing line, so you just draw it, right? So we start with the order pair 1, 3. Okay. And if you want to use in slope, so 1, 3, slope equal to 2, so 2 over 1, meaning we could go up 2 units, up 2, and go to the right 1 unit. From here, we go up 2 units, 1, 2, right? Go here, and then go to the right 1 unit, right? So that's why another point should be here. Okay, then you connect those 2 points, you also get a line. Okay. So you can use a given order pair and then slope to get another point and then connect it to get a line. Okay. Any question on this?
Can you go back one slide?
Sure.
Okay, thank you.
Okay. So let's move on. And I already talked about the parallel lines. What if 2 lines are perpendicular to each other? If one line is perpendicular to another line, and basically if 2 lines, for 2 perpendicular lines, very simple equation to describe this relationship is slope number 1 times slope number 2 equal -1. Okay. And that's why they write it as a slope for line number 1 equal to negative reciprocal of slope of line number 1 when the 2 lines are perpendicular to each other. Okay. So typical perpendicular line look like this. Let's say we have this, and one line look like this, another line will be this. Right. So they basically form a right triangle here. Okay. So that they are perpendicular to each other. And most important thing is the slope number 1 times slope number 2 equal -1. And if you know the slope for one of the line, then you'll be able to find out the slope for the other line. Okay. Okay. So now let's look at example 7. So find the equation of a line passed through the point 3, 1, and it's perpendicular to this given equation, to this line, right? To another line. So we have 2 lines, they are perpendicular to each other, and we need to find out the equation for the line passing through this point. And then what should we do? Any suggestion?
Well, first, you already know what X1 and Y1 is, so I would just identify those.
Yeah, okay, very good. Yeah, well, that, very good. Now, what else do we need? We also need a slope, right? And we know that this line is perpendicular to this, but we know the other equation 2x minus y adding 1 equal to 0, right? This is an equation for the other line. However, this equation is not in the slope-intercept form, meaning we don't know the slope for this line yet. But we can do a little algebraic transformation to get a slope first by adding y from both sides of the equation. Okay. Now, once you do that, then the y value is equal to 2x plus 1. Now we reverse it, right? So y equal to 2x plus 1. And what this tells us is the slope for line number 1, for line number 1, right? It's m1 equal to 2. And since we know the slope for one of the perpendicular lines, in order to find out the slope for line number 2, you're using the formula m1 times m2 equal -1. And m1 is 2. So 2 times m2, that should be equal to -1. Okay. So now let's find the slope for the other line. So divide 2 from both sides of the equation. Slope for line number 2 should be -0.5. That means we know the given order pair, and slope here is it's half, right? -0.5. Then we'll be able to find out equation of this line, right? By using the point slope formula up here. So what we can do is x1 is 3, y1 is 1. So we're using this point slope formula, y minus y1 equals slope times x minus x1. I'll just throw in all 3 numbers into the formula. So y minus 1 equal to -0.5 times x minus 3. Okay, now we can distribute it. Yeah, so y minus 1 equal to -0.5 x plus negative become positive. Half times 3 is 3/2. Okay. And then the very last thing is by adding 1 from both sides of the equation. Okay. Then we cancel that. So y value equal -half x. And 3/2 plus 1 actually becomes 1 is equal to 2/2. So 3/2 times 2/2, that becomes 5/2. And that's equation for the line we're looking for, right? It's y equal -half x plus 5/2 for that line. Any question on this? So the perpendicular property, right, help us find the slope for the line. Then after that, we're using point slope formula to get the equation of the line. Okay. Yeah, and if you plot the graph, and then it will look like this, right? So the line number 1 is that, line number 2, they are perpendicular to each other. You can just sketch the graph yourself, and you'll be able to get that. Now, let's hypothetical speaking, let's say we have a straight line passing through 2 order pairs. First one is 0b, and then the other one is a, 0. Meaning we know the x-intercept and the y-intercept. And how would you find out the slope? Similarly, right? This is x1, y1. This is x2, y2. So we do y2 minus y1 over x2 minus x1. I'm throwing on the numbers. Y2 is b, y1 is 0. And then x2 is 0, and then x1 is 8. Right? So we get a b over -8. So this is -b over 8. That means if we know the xy intercept, then the slope is equal to -b over 8. So we're just using the y values from the y-intercept dividing by the x values from the x-intercept. Then you get a slope, right? Put negative sign in front of it, you get a slope. And this is a quick way to get a slope given the both x-intercept and y-intercept. Okay. So now we know x-y-intercept, right? Using that to get a slope. And now we using point slope formula. So slope is -b over a, right? And we're using the order pair 0b, meaning x1 equal to 0, y1 equal to b. Now we're just throwing this into this formula here. Okay. And it becomes y minus b equal to slope, right? X minus x1, so b becomes 0, so y equal to mx plus b. And that's how they generate the other equation for the straight line. We call this slope intercept form, right? So if you know the slope, you know the intercept, typically the y-intercept, then you'll be able to use a slope intercept formula to find the equation of the line. So it will be y equal to mx plus b. And this is widely used linear equation formula. So, okay, so now let's take a look at this. Determine the slope and the y-intercept of the line whose equation is this. Okay, so you are given the equation of the line, but it's not in the slope intercept form. That means we need to do a conversion here. So you're taking equation, turning into slope intercept form by getting y by itself, right? Meaning you're solving for y. Okay, here the key thing is solving for y. Solving for the y value. Okay. That means we need to isolate a y. So first step, move x to the other side. By subtracting 3x from both sides of the equation, then we end up with -4y equal to negative 3x. This is positive 8, adding 8. Okay. Now from there, in order to get y by itself, we need to divide negative 4 across. So divide every single term by negative 4, right? That's what we mean by dividing negative 4 across. Now cancel the coefficient, then y value equal to 3/4 x, and plus minus become minus. A by 4 is 2. Now actually we turn into the slope intercept form, right? Now we'll be able to find out the slope. From there, slope is 3/4. And then y-intercept will be 0, -2. Okay. So that's what they are looking for, right? Slope and the y-intercept. Okay. Does that make sense? Any question on this? So your equation, excuse me, the equation of the line could be appear in different form. So typically we will convert it into the slope intercept form, and we nail down the slope and y-intercept from there. Okay. So now let's take a look at this application problem. So the sales manager of the local sporting goods store plotted sales, right? So this is sales and also versus time for the last 5 years, and found a point on the line. So if you look at this, which 2 points we use? Any suggestion? Look like the first point right here, right? This is exactly located on a line, and the middle 3 actually slightly off. So you probably wouldn't want to use that. So now if you look at the last point on the very top, this one is also on a line. So it's probably a good idea just use the first point, this point right here, and then last point on the top. So this point, the coordinate should be 120, right? Here sales is in $10,000, meaning this is $20,000 sales, right? For the first point. For the last point, it should be in year 5, the sales become 60,000. Okay. So that's basically how we we nail down those 2 points. And since we know 2 points, in order to find out the equation of the line, we can use the slope formula. So it's 120 and then 560, right? So we're using slope formula to find out the slope first. So this is x1, y1, x2, y2. So now it's y2 minus y1 by x2 minus x1. So 60 minus 20 over 5 minus 1. And this turned out to be 40 over 4. So this means 10 over 1, right? Simplify that. So that means 10,000 per year, right? Meaning as a year go by, the sales will increase by 10,000, meaning it's 100,000 basically, right? Let's go back to this. Sales in $10,000, yeah. So it's 10,000 is 100,000. So as the year go by, you know, the sales increase by $100,000. Okay. And then now, once we know the slope, we'll be able to find out the equation of the line, right? Using the point slope formula, y minus y1 equals slope times x minus x1. So x1, y1, we know that x1 is 1, y1 is 20. We just calculate the slope equal to 10. So y minus y1 is 20, slope is 10, x minus x1 is 1. And we just distribute it, and we get y minus 20 equal to 10x adding 10, minus 10. Okay. And now you just add 20 from both sides of the equation, add 20 here, add 20 here, and we get the equation of the line, right? So y equal 10x plus 10. So basically, first of all, we come up with the two order pairs from the graph of the line, then calculate the slope first, and after that get the equation of the line using the point slope formula. Now from there, yeah, that's exactly what we're doing here. And then we get that. So let me ask you a question. So let's say the stock manager want to make a prediction about next year, year 6. What kind of sale do we expect to have for the year 6?
70,000.
So how do you get that? How do you get 70,000?
Because the points are almost like 10,000 up each year.
Very good. So using the trend, right? Using trend to nail down that result. That's good. Also, you can plug in x equal to 6 here, right? 6 times 10 is 10, 10 plus 10. I mean, 60 plus 10, that's 70. That's why it's 70,000. Yes, that's exactly right. So a couple ways of looking at it from the graph perspective, also from the equation, right? Since we have the equation, we can utilize that together to make the prediction. So this is very important procedure for a lot of merchandise industry, right? So if you're selling merchandise or goods, this is also linear equation is very useful in terms of making prediction about the future sales once you have the historical data available, right? Yeah, so okay, so now something really quick is summarize what we did from this class in section 1.3. So vertical lines, we're using this, right? X equal to A. Horizontal line is Y equal to B. And then point slope formula and the slope intercept formula. And also we have the general forms, right? AX plus BY plus C equal to 0. And those 5 formulas are very, very useful in terms of moving forward in this chapter. The next thing I want to quickly, go over a couple questions from your homework assignments, the even ones, right? I'm not going to do the R1s. R1s is your, so we finished 1.3. So today you should work on a homework assignment from section 1.3. So now let me open the textbook. Okay, let's open the textbook. All right, and you can scroll down to the section 1.3, 1.1, 1.2, there's no homework assignment. So your homework assignment is starting on 1.3. Okay. And this class will review a lot of contents, in terms of this, but one thing we didn't talk about is determine whether the function is linear or not. So I'm gonna go over a couple questions here. I'm gonna look at the even ones like 2, 4, and 6, and you guys are gonna complete 1, 3, 5, 7 as your homework, right? Let me do that. Okay, I'm gonna show how to make determination in terms of whether or not they are parallel lines. I mean, they are straight line. Okay. So question number 2, we have this equation here. All right, so it's 3xy minus 2x equal to y. All right, so in order to determine whether or not it's a linear equation, we can use a slope intercept form, right? So basically, we're going to turn this into mx plus b. By doing that, we need to get y by itself. Okay, so first thing we do is, since this one has y, that one has y, so we're going to subtract y from both sides of the equation. Okay. So we get 3xy minus y minus 2x equals 0. So now this two terms has y, right? Keep it on the left. Now adding 2x from both sides of the equation, cancel that. So we have 3xy minus y equal 2x. Now factor out of y, that's what we are looking for. Y equal to y times, so factor by GCF, y goes outside, we get 3x minus 1 equal to 2x. Now, in order to get y by itself, we dividing 3x minus 1 from both sides of the equation. So y is by itself, so this is 2x over 3x minus 1. So is this a linear equation? What do you think? Is it? This one is not a linear equation, right? Because we cannot isolate the slope and the y-intercept. And this is what they call the rational equation, right? Rational function. So this is not a linear equation. In order to be a linear equation, we must know the slope and the y-intercept. But for this one, we cannot find that, right, from based on the equation itself. Okay, so this is question 2. And question number 4. -3 over x equal to 5 over y. Again, this is a proportion, so your first thing will be cross multiplying. So -3 times y is -3y, goes to the left. 5 times x go to the left, go to the right, right? -3y goes to the left, 5 times x go to the right. And again, we're gonna solve for y by dividing -3 from both sides of the equation. So y is by itself, and here is -5 over 3x. Is this the linear equation? Any suggestion?
I think it is because you have like the slope and probably, I don't know, I'm not sure.
Yeah, you're right. Totally. You are right, right? The y-intercept here, although it's not indicated, but you can put a 0 here, right?
Oh yeah,
always-
that's it.
you always- that will do it, right? So you're right. So this is a linear equation with a slope equal to -5 over 3, and y-intercept b equal to 0. Okay, very good. And question 6. Let's quickly get over question 6. This is question 6. So question 6 is -2y minus 8 minus 3y. I mean equal, yeah, they're equal to -8 minus 3y. And similarly, right, we're going to combine both y variables. So adding 3y from both sides of the equation. Okay, cancel that. 3y minus 2y, that's y, and equal -8. Is this a linear equation? Any comments? Any thought? Y equal -8, is it linear? Okay, yeah, this is a linear equation, right? Because we can always write it as, and this is a special type of linear equation. We call this, this is similar to y equal -8. So it's what we call a horizontal line, right? Horizontal line has a format of y equal to this. And you can also view this as 0x minus 8, right? Now in this case, we know that slope is 0 because for all the horizontal lines, slope is 0, and the y-intercept is -8. Okay, this is also a special type of linear equation. Okay, so, and that's gonna be it for the lecture part. Any question, anything in general? Okay, so I guess we will sign off here. So I talk to you guys on Friday then. Okay. Bye-bye, guys.
Thank you, Professor.
Thank you.
No problem. Bye.
Thank you. Bye.
Thank you.
Okay.
Thank
Talk to you
you.
guys on Friday. Bye.
Thank you.
Okay. I will post the lecture video right later on. Okay.
I have a question.
Sure. Go ahead.
Okay, so going back to linear depreciation,
Yeah.
when you did an example,
Mhm.
it's the one when they had a scrap value, and then
Right,
we
right, right.
solved and we found that it was 1,400 per year.
Mhm.
After that, you did another example, and I kind of got confused there. I don't know if you could go back in the slides.
Sure. I think it's probably in the section 1.3. So it should be here. Should be on top. Okay. Let me find a question first, and then
Okay.
you. It's very good question, right? In terms of the depreciation, is that. Let me share that with you. Okay. Share the screen with you. Okay, this one, right? Is that about network server?
So I understood the first one, but I kind of got lost once you did V equals M times T. Plus-
Oh, okay.
Yeah, that I didn't get.
Okay, I see. So the value is like a y, right? And then t here is like x. So it's like y equal mx plus b. Same idea. So this is equivalent to y equal to mx plus b. But it's in the real context. So there are only two variables here. One of them is the value of the network server. The other one is the time t the company is using the network server. And here the value is depreciating on a yearly basis, right? So every year you go down negative $1,400
Oh, okay.
times t, and then the initial value is $10,000, right? Because it's mentioned in the question. So that means if your time t is 1, then you throw in the 1. If time t is 2, throw in the 2. Then you'll be able to find out remaining values for the network server. So that's why negative 1,400 here serves as a slope, like how much the value go down on a yearly basis.
Okay, that makes sense.
Okay. Well,
Um,
just any other question?
So wait, and then what's the 714 at the bottom?
Oh, 7.14.
Yeah.
That's when the value becomes 0. So I have a follow-up question in the during that time. So I ask you, when does the network server has 0 value, 0 residual value, meaning it has no value at all?
Okay.
That means total remaining value v equal to 0. And that means negative 1,400 t plus 10,000 equal to 0. And then we try to solve for t. And t turned out to be 7.14, meaning somewhere between 7 and 8 years, the server lose all the values.
Say that again.
So what I try to say is, so turn out to be t equals 7.14, right? So that means somewhere between year 7 and year 8, you know, the server loses all the values.
Oh, okay.
0 value.
Okay.
Yep. Okay.
And then just one last question, sorry.
Mhm.
So we don't have any homework from last week, but it starts this unit like 1.13 you were saying.
1.3, right? So your first homework is right here, right? Today on the exercise 1.3, 1357. I did the other 3, right?
Yeah.
So you can complete 1357 for today. Okay.
Alrighty. Thank you so much.
Okay, no problem. Okay. Bye-bye.
Bye.
Okay.